Okay, so boys, we're going through some more examples, some practical examples. So if we have a look over here, we have a ladder 20 metres long is placed against a building. So here's my building, here's my ladder, it's 20 metres long and it's leaning on the building. If the ladder reaches 16 metres up the building, so this is 16, find the ladder's angle of inclination to the building. Now it's these two things we're looking at. So it's the ladder itself and the building, we want the angle between them. So we're looking for that angle there, between the ladder and the building. So we've got adjacent, hypotenuse, so we're doing cos, so it's cos theta equals A over H. Substitute in, so we've got no angle, so it's cos theta equals 16 over 20. Get rid of cos, come over and do the opposite. Inverse cos 16 over 20 on your calculator will give us, put it into your calculator the way we've been doing it, so it's shift cos, then we're doing a fraction key, 16 on the top, down arrow, 20 on the bottom, right arrow out of your fraction, press the bracket, and that's what answer we get. We're going to the nearest degree, so I'm going to write that answer down. That's in degrees. We're going to the nearest degree. So we want the nearest whole number, and that will become 37 degrees. Okay, the next question. We have a pile of wheat. It's in the shape of a cone. It has a diameter of 35 metres and measures 27 metres up the slope to the apex. So we're going to draw a shape of a cone. The diameter of 35 metres goes from here to here, right across the circle. The 27 metres goes up the slope to the apex. So we're going up the slope to the apex. The apex is the top of the cone, the top point of the cone. We're asked to find the angle of repose. Now they explain what that is, the angle of repose of the wheat. So it's the angle that the sloping side makes with the horizontal base. So here's your sloping side, here's your horizontal base. It's the angle between them that we're looking for. So there's where our theta is going to go. You can see that we've got a right angle triangle here, right? So even though they didn't give you a right angle triangle, you can go straight from the apex down. It's going to hit the centre of the circle on the base shape down the bottom there. Okay, so we're looking at a bit of a cross section inside this three-dimensional shape. All right, so if this is 35 from here right across for the diameter, this is going to be exactly halfway. So 35 divided by 2 will give us 17.5. All right, so that is 35 divided by 2. Because it's very symmetrical, this shape, and everything is splitting in half. Okay, so that's 17.5. If we label our sides, this is our adjacent side, and this is our hypotenuse. So we're using cos. Cos theta equals A over H. If we sub in, we don't have our angle, that's what we're looking for. So it's cos theta equals 17.5 over 27. Put that in. Then we're going to get rid of our cos. Come to the other side, and we're doing inverse cos of 17.5 over 27. So it doesn't matter that you've got a decimal on the top, you still enter it in the calculator the same way. It's shift cos, fraction button, 17.5 on the top, down arrow, 27 on the bottom, right arrow out of your fraction, close your bracket, equals. Now after that, don't forget we're pressing this button because we do want an answer in degrees and minutes. Now they haven't asked for it here, but any time that they just ask for an angle and they don't say what they want it in, you always assume nearest minute. So if they don't specify, we're going to the nearest minute. Okay, so we do press that button, it gives you that. We're going to the nearest minute. That's greater than or equal to 30. So this is going to go up by 1 and become 36 minutes. Okay, next question. Now this is a ladder. The legs of this ladder. So when you open up the ladder, the legs of the ladder are 3.5 metres long. Right, so I've already put the 3.5 metres on one of the legs of the ladder. When opened fully, the feet of the ladder, the bottom of the two legs, are 1.8 metres apart. So from here to here, 1.8 metres. Calculate the angle between the legs of the ladder. Now here's the two legs. The angle between the legs is this one here. Now that's what we're going to find. I'm not even going to write anything there at the moment, but that's what we're looking for, the angle between the two legs of the ladder. Okay, so now we're going to draw our right angle triangle. Now remember, this ladder, these two side lengths will be identical. So you've got an isosceles triangle. Isosceles triangles, you can always split down the middle. Right, and it's going to be an axis of symmetry when you do that. So it'll split everything into half. Angles will be split in half, sides will be split in half. So we're going to draw this. I might actually use a different colour here. So we're going to draw this in like this. There's your right angle triangle in blue. And we're going to concentrate by finding the angle here, which I'm going to call theta. Alright, so just looking at the blue triangle. The 1.8 down the bottom there, that was going from here to here. We're splitting it into two equal bits, so this bit will be 0.9 metres because I did 1.8 divided by 2 to get that. And then we label our sides. So we're looking for this angle here, so that's our opposite side and our hypotenuse. So we're using sine. Sine theta equals O over H. Sine theta equals 0.9 over 3.5. Then we're going to get rid of sine by doing inverse sine. Use your calculator. Now I've jumped ahead a step here because when you get the hang of this, you won't need to write down the degrees, minutes and seconds. You can do your rounding yourself. It will be 14 degrees 54 minutes rounded to the nearest minute. Now once you've got that, that's not answering the question. You've just found that blue angle there, theta. I marked it as theta. But what we're trying to find is that angle. Now because you know that this is an axis of symmetry in this isosceles triangle, you know that these two bits are exactly the same. So once you find theta, you just times it by 2 to get that full angle. And once we do that, we're going to get an angle between the legs of 29 degrees, 48 minutes. So have a practice with this in your homework. I think you'll be fine. You don't need to copy out the words in the question, but there'll be a lot of word problems where you'll need to draw your own diagram, make sure your diagram's right, and then continue starting with your formula, sine, cos or tan ratio that you're doing, and continue on from there. If there's any problems, let me know.